Have you ever just looked around a totally packed city street and thought, man, are we eventually going to run out of room or resources? I mean, are we on a crash course with the literal limits of our planet? Or are we just adapting to a rapidly changing world? Well, welcome to This Explainer. Today, we are going to unpack the wildly fascinating, sometimes terrifying, and honestly, ultimately hopeful math of human population. We're going to dig into the hard data and some classic historical theories to understand exactly how populations grow, why they occasionally just explode, and what all of this means for our collective future.
Okay, let's dive right into this. Here is our roadmap for today. We're going to kick things off with Malthus and the population race. Then we'll break down the vital metrics of growth. From there, we'll explore the demographic transition theory, apply it directly to India's population explosion, and finally, look at the incredible potential of the demographic dividend.
Section 1. Malthus and the Population Race. The Terrifying Math of Thomas Robert Malthus.
To really get a grip on population dynamics, we have to travel all the way back to 1798. That's when an economist named Thomas Robert Malthus propounded this theory in his famous book, An Essay on the Principle of Population. He basically framed human existence as this high-stakes mathematical race. See, Malthus noticed that the human population increases in a geometric progression, meaning it multiplies like 2, 4, 8, 16, 32, and so on. But our actual ability to produce food, well, that only increases in an arithmetic progression. We're just adding 1, 2, 3, 4, 5. You definitely don't need to be a math genius to spot the terrifying imbalance here, right? Human multiplication vastly outpaces the simple addition of our food supply.
So, what happens when we inevitably hit that crisis point? Well, Malthus stated that the correction of this massive imbalance is handled by one of two checks. First up, you have preventive checks. These are basically human-driven actions that lower the birth rate, things like late marriage or moral restraint. Then there are what he pretty grimly called positive or natural checks. This is nature's brutal way of balancing the scales through natural calamities, famines, and disease, which basically operate to wash out the excess population. Now, while those positive checks were bound to happen if we weren't careful, Malthus strongly believed that preventive checks were far more dependable for maintaining that delicate balance.
Section 2. The Vital Metrics of Growth. The Demographic Toolkit.
So, while Malthus gave us the historical foundation, modern demographers actually use a very specific toolkit to track this race today. First up is the birth rate. This means the number of births occurring per thousand of the living population during a single year. You'll also hear experts call this the fertility rate. It is essentially your baseline measurement for how fast a given population is adding brand new members.
And right on the flip side of that equation, we have the death rate. This one is pretty straightforward. It's the number of deaths per thousand of the living population during a year. It's also commonly referred to as the mortality rate.
Now here is the absolutely crucial point, the survival rate. This is simply the mathematical difference between the birth rate and the death rate. This single metric shows us the actual real-time rate of population growth. Think about it. If you have a sky-high birth rate but an equally high death rate, your survival rate is low and your population barely moves. The real population explosion, that lives entirely in the widening gap between the birth rate and the death rate.
Section 3. The Demographic Transition Theory. How economies change populations.
All right, now that we have our core metrics down, let's see how they actually shift over time. Back in 1958, A.J. Cole and E.M. Hoover gave us the demographic transition theory, which beautifully links economic development right to these population metrics. Basically, every country passes through 3 stages. In stage 1, that primitive pre-industrial stage, poverty and a total lack of modern medicine mean high death rates. So people naturally have many children to compensate. The result is low overall population growth. Now, skip to stage 3. These are fully developed countries with high education and urbanization, which naturally leads to low birth and death rates, giving you a stable population again. But stage 2? Stage 2 is the volatile danger zone. This is the developing stage. Economic development brings way better medicine, so the death rate just plummets. But social attitudes haven't caught up yet, meaning the birth rate stays incredibly high. High birth rate minus a falling death rate? That equals a massive population explosion.
Section 4. Inside India's population explosion, a real-world case study.
Let's actually apply this brand new demographic toolkit to a real-world case study and see how this builds. I want to anchor our history on one very specific year, 1921. Demographers actually call 1921 the year of Great Divide in India. See, before 1921, India was firmly stuck in stage 1 of that demographic transition. They were actually experiencing negative growth because of devastating epidemics like influenza, cholera, and the plague. But right after that Great Divide of 1921, the country saw a continuous, practically unstoppable increase in its population.
And the historical data brilliantly illustrates exactly why an explosion like this happens. When you track the numbers after 1921, and especially moving into the 1950s and 60s, the death rate absolutely plummets. This was thanks to widespread improvements in medical facilities, better disaster management, and wiping out major epidemics. India had officially entered stage 2. But here's the catch. While the death rate fell off a cliff, the birth rate stayed stubbornly high for decades, creating a massive mathematical gap. And as we learned, that gap literally is the population explosion.
To really bring that abstract data into the real world, just think about the physical landscape. Back in 1961, resources and infrastructure were generally operating at a normal capacity. But by 2011, over just a few short decades, that exact same infrastructure was completely overflowing. Between 1971 and 2001 alone, India experienced an annual population growth rate of more than 2%. The sheer density of human life totally transformed the landscape, putting this immense, unprecedented pressure on agriculture and basic daily amenities.
So, you're probably wondering, why did the birth rate stay so incredibly high for so long? Why was India stuck in that volatile stage 2 of the transition? Well, it really comes down to deep-rooted socioeconomic factors. When you have widespread poverty and a massive overdependence on manpower-driven agriculture, having a large family isn't really seen as a burden at all. Honestly, it feels like an economic necessity. You just need more hands for the fieldwork. Add to that the traditional joint family system where financial responsibility is spread out, a really strong cultural preference for male children that leads families to keep trying for a son, plus lower levels of literacy, you end up with a society where the birth rate remains deeply entrenched, even as modern medicine is keeping everyone alive much longer.
Section 5. The demographic dividend, the ultimate resource. Up until now, we've kind of talked about population explosions as a huge problem, right? Like a classic Malthusian crisis of resources. But here's the thing. Nature's bounty only actually becomes a resource when human beings have the demand and the ability to use it. Therefore, human resource is the ultimate resource. A demographic dividend happens when a country's population structure shifts so that the proportion of working-age people is incredibly high compared to dependents, like young children or the elderly. When a country smartly invests in education, health, and nutrition for this massive working-age group, that sheer volume of human capital turns into a massive competitive advantage. It offers uniquely high potential for explosive economic growth.
Which brings us to our final thought for today. For centuries, Malthus had us looking at population math with this lingering sense of impending doom, right? Viewing every new person as just another mouth to feed in a geometric race against our agricultural limits. But when we actually look at the reality of demographic transitions and the amazing potential of a well-educated demographic dividend, the script flips entirely. So I leave you with this question to ponder. As we look to the future, is a massive population truly a burden on the planet? Or, if nurtured correctly, is humanity's greatest asset actually just our sheer numbers? Thank you so much for joining me for this explainer. Keep questioning the math and keep learning.